Hello everyone. So let's now solve practice assignment week 7, question number 5. Consider a vector 1, 2 from the inner product space R2, where inner product is the dot product. Which of the following options are true? There exists a vector u which is not equal to v in R2 such that norm of u is equal to norm of v. Now, as no information is given what is the norm, so we will consider the usual norm, that is the square root of general inner dot product. Option 1. So first, we will check for the norm of v, and that is the square root of 1 square plus 2 square, and that is under root 5. So this is the we have taken the general norm. So this is the norm of v. Now let's say, for example, if we consider u to be our 2 comma 1, and then we'll find the norm of u, then again we will get the same answer, that is root 5. So yes, there exists a vector u which is not equal to v in R2 such that norm of u is equal to norm of v. So first option is correct. Second option, there are infinitely many vectors in R2 such that norm of the vectors are equal to the norm of v. Now, geometrically, the standard norm represents the distance of the vector from the origin. That means, consider our origin. Consider this is from our axis. Now, we have our point 1, 2 here. Now, geometrically, our usual norm would be nothing but the distance of this point from the origin. So, that would be something like this. Now, if we want to check that there exist more vectors such that this distance that is represented by our general norm would be same or no. So, yes, there exist infinitely many points, as we can draw a circle with taking this distance as the radius of the circle from here, and all the vectors that lies on the boundary of this circle are all those vectors whose norm would be same as the norm of this vector. So that means we can draw this circle something like this, and all the vectors that lies on this boundary would have the same norm as this vector, and mathematically or algebraically we can represent this as, so option 2, we can represent this as the set. Now the equation of the circle is uh, x square plus y square equal to r square, where r is the radius. Now we are taking radius to be this, that is the norm of the vector 1, 2, or in other words, the distance of this vector from the origin, and that is root 5. So r square would be root 5. So if you consider the set x, y such that x square plus y square equal to r square, that is 5, then if you take any x, y which satisfy this property, that is x square plus y square equal to 5, all those vector norm will turn out to be the same as the norm of 1, 2. Now that means this option would be true. Third option, there exists a vector u in R2 such that u comma v dot product of this is equal to 0. Let's check that. Now our vector v is 1, 2. Consider vector u to be minus 2, 1, And if we take the dot product of v and u, that would be minus 2 plus 2 equal to 0. So if there exists one vector such that the dot product of these two vectors turns out to be 0. So this option is again true. Now fourth option, there are infinitely many vectors in R2 such that angle between the v vector and the v is equal to 90 degree. Now, so we know that cos theta is equal to u v divided by norm of u into norm of v. So the the cos of any angle between the two vectors is defined as follows. That is the inner product of between vectors divided by the norm of those two vectors. Now it is given that the angle between the vectors are 90 degree. So cos of 90 would be cos 90 is now inner product between u. Consider u to be some vector x comma y, and as we are taking the standard dot product, and our this would be under root of x square plus y square times under root 5. Now cos 90 is 0, so and x plus 2y under root of x square plus y square under root of 5, and we will get x plus 2y is equal to 0. So that means any vector which satisfies this constraint, that is x plus 2y equal to 0, will have the angle with the vector v to be 90 degree. So there can be infinitely many vectors like that. So there exist infinitely many vectors in R2 such that angle between the vector and v is equal to 90 degree. So fourth option is also true. Thank you.